Welcome. Today I'll be briefly talking about regression parameters, and so I'm going to define what a regression is, talk about regression coefficient, and then just give some examples on where it's useful. And so to start, a regression is a measure of how strong or weak variables are with each other. So we'll have two or more variables or parameters. A regression line is essentially the line of best fit, and the slope is the regression coefficient. We can figure out unknown parameters with these regression coefficients. So on the right, I have drainage rates. On the y-axis, drainage amount, and x-axis is time. And so we are testing different media types in the stormwater lab, testing how permeable these media types are. So this is one example, I believe, BAM. And so we plotted the data points and then drew a line of best fit through it, and this is an example of a linear regression. And on the next slide, we'll talk about how strong these two parameters are with each other. So determination of relationships. So each regression model uses different formulas for linear relationships, linear regression, which we focused on in this course. We can use the coefficient of determination. And this is essentially r squared, so when we run ANOVA, we can figure out r squared quite easily. And that's exactly what I did for this example. So I have my data points, which were plotted in the last slide, and now I have the regression statistics, and I have r squared. So we have 0.99 right here, and we don't know what that means because I haven't told you what's good and what's bad. So essentially, we want r squared to be as close to 1 as possible. Anything close to 0 means it's a weak relationship, so anything close to 1 must mean it's a strong relationship. So 0.99 is pretty good, I would say. So we can be pretty happy with that and say that these two drainage rate and or drainage amount and time are have a strong relationship. So here's the rest of the ANOVA data. So to continue, we use ANOVA and linear regression, regression in general, in environmental engineering for most of our work, water quality, stormwater, coastal modeling. I've seen it a lot in coastal modeling. And on the example on the right, this is a polynomial regression. I've seen Dr. Wall use a thing called WASP, and